So everything that we'll be doing, make sure that you've got a pen where you are able to write the notes that I'll be giving here. So we defined what a simple machine is, what a machine is. And we also looked at the types of simple machine. This is what we talked about. This is what we discussed previously. Should be on Thursday or Friday, somewhere there, last week. So now we also went as far as looking at mechanical advantage. We talked about mechanical advantage, where I said mechanical advantage, it was like this, MA. This was mechanical advantage, where we said mechanical advantage is equal to load over effort. This is what we discussed. I just want to make sure that we get to move together. So we said that mechanical advantage, this is mechanical advantage, is equal to load over effort. I gave you the definition of effort. I also gave you a simple definition of effort and load. I gave you the definitions of these two, where I said that the applied force is called effort. So the effort here, this is the applied force. We know that this is the applied force. This is what we discussed last time. This is the applied what? Applied force. Then we also have the load. Here, what is the load? If maybe you are behind with this, so what is the load? The load, we said that the force which effort overcome. So this is the what? The force which effort. So this is the force which effort overcome. This is what we talked about last time. I remember very well. This is what we did. This is what we talked about. So I believe you are able to understand this. So this is what we discussed. I also gave you certain questions which we did a wonderful work. So let's continue working hard. That was really awesome and great. Almost everyone got everything correct. That was a sign that we understood the topic. So even as I'm explaining, if you've got a question, don't wait for me to say. If you've got a question, if you see that I've used certain theories or a formula which you are not understanding, you can say, sir, I've got a question. Before you continue, I can respond to you. So when you've got a question, you can please notify me. You can unmute yourself and say something. I know that, okay, I need to explain more on this part and this part. Today we are going to continue with this same topic, but we'll be looking at another thing which is different. So we can now start writing from here. We'll be looking at this is what we'll be looking at. It is called the velocity ratio. This is what we'll be talking about. Velocity ratio as VR, like that. So let's write something here. So this is what we'll be looking at. This is called the velocity ratio. So what is velocity ratio? In your own words, what is velocity ratio? So before you get to look at something, before you answer any question in an exam, you need to know what you are answering. You need to know the concept. The concept you are applying, you need to make sure that you know it and you understand it. So what I'm going to tell you is this. Velocity ratio, we know that we are talking about machines. So even the definitions should be similar to machines. So velocity ratio, this is just a ratio. So is the ratio, I want you to write this definition, is the ratio of the what? I'm going to use the letter D. This is distance. Is the ratio of the distance moved distance moved by effort. So the distance moved by effort to distance moved by the what? Distance moved. So I'm going to do this by the load in the same time. This is the what? The definition for velocity ratio. Very simple. Have you seen? So what have we said? We've said that this D there is distance. So make sure that you understand it clearly. That's distance. That's distance. So velocity ratio is the ratio of the distance moved by effort to distance moved by the load in the same time. This is what we are really talking about. So what is the formula now? So formula, the good part about physics is that once you know the definition, then you know the formula. Because you can forget the actual definition, but the formula itself is also a definition on its own. So what have we said here? We've said that velocity ratio is the ratio of the distance moved by what? Effort. So we are saying that this is the distance. You say distance moved by effort. You do this. Over, you know that it is the ratio. To distance moved by the load. So distance moved by what? Load. I'll put L there. Like this. This is what I'm going to do. So have you seen the formula? This is the formula for what? This is the formula you need to use whenever you want to find the velocity what? Velocity ratio. So make sure you keep these definitions. Make sure you are able to note something. You are able to write down certain notes on this. So the way physics is all about applications. We don't have like a lot of notes in this because this is all about calculations. You get to analyze things. So I want you to understand me clearly. I want you to get me. So for those of you that are facing network challenge, this video is recorded. So even after this lesson, I'll be able to share the video in the group so that everyone can access it. Hope we are able to see this definition which I've given here, where I've said the velocity ratio is equal to distance moved by effort over distance moved by load. It's different with have you seen the way this one is? This one. This is mechanical advantage. Mechanical advantage is just load over effort. But when we go to this one, let's move. When I go to this one here, this is what? This is velocity ratio. Velocity ratio, I'm now talking about distance. Another thing here. Distance moved by what? Effort over distance moved by load. So this is what you need to know. This is what you need to understand. Hope you are able to see. Hope you've understood this. Before I even continue, anyone with a question where you haven't understood, let me know so that even as I proceed, I know that we are all clear. So anyone with a question, just here. If you've got a question, you can ask me. I answer that question. So if you've got a question, you can ask me. Ask me. Anyone with a question, you can ask me. If you've got a question, you can ask me. So anyone with a question, ask. Okay, no one is having a question. So it means that we've all understood and we are clear on this one. Okay, this is good. People are understanding. People don't have questions to ask. Okay, so let us now proceed and look at other things. So I believe you are able to write these notes slow as I can, so that I also give you time to write these. You understand them clearly. So this is what I want you to do. Let us now look at another thing here. Before we even proceed, let us look at another thing before we proceed. So we are still under this same topic. This is the same topic that we are doing. So we look at another thing which is different to this. We look at another thing, another question. So calculate. This is a question. I want you to write down this question. This is a question. Calculate the velocity. Calculate the velocity ratio. So calculate the velocity ratio of the diagrams below. So we want to calculate the velocity ratio. How can we calculate the velocity ratio? Let's say there is a person here. This is a person. I'm going to do this. There is a person here. This one is a person. This is a person here. This person is pushing this thing here. It's pushing this thing which is here. It's pushing this. Something that is like this. The person is pushing this like this. So this is what is happening. Then we know that here, this is like something that is balancing this. There is something here that is balancing. So from here, we know that from where this is to where the person is standing, we've got a distance. A distance of what? We've got a distance of 1 meter. So there is a distance of 1 meter. But from where this thing is to here, we've got a distance of 50 centimeters. This is what we are actually having. The question is saying we calculate the velocity ratio. How can you calculate the velocity ratio in this question? The first thing you need to do, write the formula. You know that velocity ratio, I'm going to do this. Velocity ratio is equal to distance moved by what? Effort over distance moved by what? Load, like this. So you ask yourself, what is the distance moved by effort? Where is the effort? The person is here. This is where effort is. Have you seen? This is where the effort is being applied to overcome this load. So from here, where the person is standing, to where the load is, have you seen? This distance is called effort. Have you seen? This is effort. So to give you a clear picture, effort is being applied from there. So let me do this. Maybe we are going to understand it this way. Like, so this is a dotted line just to show you. Effort is being applied there. So up to there. So this distance from here to there, this is the distance covered by effort. So that is 1 meter. So you say 1 over. Then the distance moved by the load. What is the distance moved by load? Distance moved by load, this is the distance. Have you seen? This is just a distance moved from here to there, which is what? 50. So this is what? 50. You know that it is in centimeters. 50. So this is 50. You know that it is in centimeters. How do you convert to meters? You need to divide by what? 100. So when you divide by 100, what are you going to get? This is a 0.5. You are going to get 0.5 meters. So this is the distance moved by load, which is here, the load. So this is the same one you're going to put is 0.5 like that. This is what you're going to do. So 1 divided by 0.5, what is your answer? What is your answer? When you use your calculator, you're going to get what? 2 as your answer. This one has no units. It is a ratio. We are saying velocity ratio. Even mechanical advantage has no units. These are ratios. We are talking about ratios. So make sure we understand it that way. I noticed we were making mistakes on that part. So some people were putting units. This one has no units. But before dividing like I did here, you don't need to get the same 50 centimeters, then just put it there. No, you know that on top you are having meters. Even down here,